Hey guys, welcome to Chapter 9. We're going to start off with some sequences and series and pay close attention because it's a review for now, but third quarter, and I know you've heard all kinds of things about third quarter of Calc BC, it is going to be the hardest and it's going to be we're going to dive really deep into series. So make sure you've got the basics down, okay? So there's two different types of not true. We're going to look at two different types of sequences and series today. So just looking at a sequence. Now, a sequence is just a list of numbers, okay? We can make up any kind of sequence that we want, any random sequence. You know, a kindergartner can make up a sequence, just a random list of numbers. But the two types of sequences that we're going to look at are arithmetic and geometric. So, for an arithmetic sequence, the list of numbers have a common difference. So you can see that the common difference here in this sequence is 4. All right, so some things that are going to be important, like some vocabulary that we're just going to be using over and over and over again. We're going to look at the first term of the sequence. We're going to look at the common difference, like what was added each time. We're going to say, all right, how can I define this sequence explicitly, and how can I define it recursively? So let me start with this one. Defining a sequence recursively means just basically how do you pick up where you leave off? Like how do you get the next term? How do you get the next term and the next one? So when you define a sequence recursively, you've got to consider each number from the first term all the way to the term that you want. When you define a sequence explicitly, this is really cool. We're going to write an equation for it. So if I want you to tell me the 100th term of the sequence, you can jump to the 100th term very quickly. If all you have is a sequence defined recursively and I want you to jump to the 100th term, holy moly, that's going to take a while because you have to work your way to it using this formula. So again, just on arithmetic sequences, here's an example of another one. First term, common difference this time is -6. And we can define it explicitly, jump to any term you want, or recursively, where we constantly have to look back to the previous term to get the term that we want. For geometric sequences, this time, again, list of numbers. We're going to pay close attention to the first term of the sequence, and this time we're going to look at our common ratio, or what is being multiplied each time to get the next term in our sequence. We can define it recursively, and if you define it, we can define it explicitly, which allows us to jump to any term we want. And this is going to be your first term goes here, your common ratio goes here, and this is always n-1. I'll talk about that more later. Or recursively. We can define it recursively, and that's where you need to take into consideration each one. If I need you to tell me the 9th term, you have to know the 8th term if it's defined recursively. Another example of a geometric sequence, maybe you're not multiplying each term by an integer, maybe you're multiplying each term by a fraction. It's very common. So multiply by a third, multiply by a third, multiply by a third, and so on. First term, common ratio. This is what it looks like when it's defined explicitly. This is what it looks like when it's defined recursively. And then you can also have a geometric sequence that alternates in signs. So we've got our first term here. If we're multiplying each time by a negative, you can see how your second term would be negative, your third term would be positive, and so on. First term, this is explicitly defined. First term, common ratio, or recursively. You can see that we're multiplying by -2 each time. Okay, so there's just a few examples. You're going to have, so you learned formulas in Algebra 1 no you didn't. You learned formulas in Algebra 2 and again in pre-cal on how to define sequences explicitly and recursively. Let me go over those with you again. Again, I'll do arithmetic over here and I'll do geometric over here. So to define an arithmetic sequence explicitly, you're going to write A sub n. A sub n represents any term. If n is 1, then this represents your first term. If n is 2, then this represents your second term, and so on. If you want the 100th term, you're going to write A sub 100 equals, and then we're going to get our 100th term, okay? So this is just notation, just telling you what this stands for. To get any term, you need to start with your first term plus D for your common difference times the quantity n minus 1. Now, what this is going to do is it's going to take into account your first term, and it's going to add your common difference however many times you want it to add it to your first term to get your 100th term. So if you wanted the 100th term, you would plug in 100 here, A sub 100. You need your first term, you need your common difference. You would sub in 100 here. What that means is you would be adding your common difference to your first term 99 times. Okay? And then to define it recursively, we can say to get whatever term you want, look at the term behind it, and then add the common difference. So you want the 100th term? Okay. Take the 99th term and add your common difference to it. Remember, recursive always looks back to, well, what was the previous term? And then I can tell you what the term is that you want. Or sometimes you'll see this. Sometimes you'll see, got a term? How about we add our common difference to it? What we get, if we have a term, we add our common difference to it. What we get is the next term is A sub n plus 1. This one's the most common for a recursively defined sequence, but this is a thing. I don't know. It may come up. For geometric, we can go explicitly for geometric. Explicitly. To get a term, you want to jump to the 100th term? Here's how you jump to the 100th term. A sub 100 equals, you need your first term times your common ratio to the n minus 1. Right? So let's pick, let's see what happens. So this is our first term. What happens when I sub in 1 for n? Well, you say that this becomes A sub 1. You're like, but we already know what the first term is. No. Just watch the math, though. It's kind of cool. To look at the first term, this is A sub 1 equals A sub 1 times my ratio to the 0th power. To get the second term, right? Second term, plug in 2 for n. To get the second term, you take the first term times r to the first power, which means to get our second term, we're taking our first term times our common ratio once. And then third term, we need to back it down 1, 3 minus 1 is 2. That means we're multiplying by our common ratio twice. To get from our first term to our third term, we need to multiply. The recursively defined geometric sequence looks like this. To get a term, take your previous term and multiply by r. Alrighty, now, before moving on, I want to kind of point something out to you. And this is on a arithmetic sequence. So this is the explicitly defined, this is how you explicitly define an arithmetic sequence. To get a term, you start with your first term and you add your common difference one fewer times. Take a look at this. This explicitly defined sequence matches this sequence, okay? But it's been simplified. So you can kind of see that this explicit equation started out, we could have started it out looking like this. But, you know, this has been distributed. You know, we simplified, we collected some like terms and stuff like that. An arithmetic sequence, when explicitly defined, looks like the equation of a line. Y equals m x plus b. This number is significant even though we've never even mentioned it yet. So think about this. If this represented the equation of a line, my slope would be 4. What would my y-intercept be? My y-intercept would be -1. What does a y-intercept have anything to do with a sequence? Well, my y-intercept is what I get when I plug in 0 for x. What's the significance of plugging in 0 into an arithmetic sequence? Well, it's kind of like I'm asking you for the 0th term. If this is the first term, I know this is so weird, but think about it. Back up one. What would have been the 0th term? Well, the 0th term would have been -1, aka my y-intercept is -1. So here's what's cool. If you know your first term and your common difference, and you want to make an explicit equation, one option is to memorize that formula. Absolutely. You learned it in Algebra 2, you learned it in Pre-Cal. Memorize this formula, plug them in, and simplify. Or know your way around an arithmetic sequence and say, okay, my explicitly defined equation is my common difference times n plus my 0th term, which we don't usually talk about, but that's what it is. This is the 0th term. I think that's kind of cool. Moving on. Examples on the back. I'm given, the two on the left are arithmetic sequences, it tells me so. Identify some stuff about it. So, common difference. For the first one, it looks like we are adding 3 each time. So I'm going to say D equals 3. Find the 9th term. Well, that's not too hard. I don't really need a formula to find the 9th term. I already have 5 of them, and I'm just adding 3 each time. So 5, I need the 9th term. So 10, 13, 16, 19. Label it correctly. The 9th term is 19. Define it recursively. To get a term, take the previous term and add 3. Define it explicitly. I think I'm going to kind of show you both ways. I can do the formula. A sub n equals a sub 1 plus d times n minus 1. There we go. Here's the explicitly defined equation. Did I have to start here to get it? Did I have to start with this one? No, you didn't. 3n minus 8. All you had to do was come up here and say, okay, d is 3. If I were looking at this from a slope standpoint, 3 would be my slope, and back it up 1. So my 0th term would have been negative 8. My y-intercept would have been negative 8. Okay, so a couple ways to get here. Pick whichever one you like. Moving on, still with arithmetic sequences. Now, it tells me it's arithmetic. If you just glanced at this one, you might not know right away that it's arithmetic, but it is arithmetic. It tells us so. So, it's up to you to figure out what has been added. What was added to this to get to this? What was added to this to get to this? To figure out what was added, why don't we grab a couple and subtract them? Let's subtract these two to figure out what was added. So, logarithms, you know what to do. Common difference is natural log of 3. Part B. Part B says, let's get the 9th term. You know what? I think we're going to do that later. Let's get our equations. Let's get our recursive and explicit equations, and then let's come back to part B. I think it'll be easier this time. So I'll skip that one. C says, write a recursive rule. Pfft, those are easy. They're easy, but we don't really use them that often. And the explicit rule, you can either, in your mind, back up to the 0th term, or if that's a little too difficult in this problem, you can always start with the formula. So a sub n equals a sub 1 plus d n minus 1 this is my slope. This is kind of like my x, okay? And then I've got these two constants, and if I flipped those around, this would be plus ln2 minus ln3. So I can say a sub n equals n times ln3 plus natural log of 2/3. Because this one would be negative, this one would be positive. When I condensed them, the 3 would be on the bottom. Now, let's use our recursive formula to come back and do part B. I can do a sub 9 is equal to 9 times ln3 plus ln 2/3. Let's see what we can do with that. Move your coefficient up and put it as an exponent on the 3. Condense with multiplication. So condense these two, multiply together, and this is basically one of these 3's cancels out with this 3. So I have ln 2 times 3 to the 8th, or if I multiplied it out, I could say ln of, what did I get? 13,122. I think really either way to write it would be just fine. Oh, that should be a 9. My bad. Need to label this correctly. That's the 9th term. Okay, moving on. Geometric sequence. It asks for a common ratio. So they alternate in sign. Common ratio is -2. Kind of weird, but definitely a thing. Like we're going to see that over and over again. I think we'll skip part B right now, finding the 10th term. Let's go ahead and get our recursive and explicit formulas. The recursive is take your previous term times -2. I don't like the way that looks. That's a lot better. Explicit formula, to get a term, take your first term, multiply by r this many times. Oh, hold on, first term. First term was 1. Now I can use this formula to get the, what's it ask for? The 10th term. Let's find the 10th term. I'm going to start with the first term times my common ratio to the 10 minus 1. And I got -512. Next one, common ratio. Oh, wow. So this first term is like 1 over 10 squared, or 1 over 100, 1 over 10, 1, 10. You can see that we're might not have been as obvious here, but once you see that you're multiplying by 10, you're like, oh, yeah, it makes sense. Multiplying by 10. I think I'll skip part B for now. Recursive. Explicit. First term, r to the n minus 1. And it wants the 10th one. So a sub 10, first term, times 10 to the 9th. And so I just took, this is to the 9th, this is to the 2nd. Just canceled out 2 of those, and that's what I got. And one more on the back. We've got the second term is 6. Don't know third, don't know fourth. The 5th term is -48, and it says it's a geometric sequence. So those are the 2 we know. Here's what we don't know. Okay, we don't know the first or the third or the 4th term or whatever, but it's okay. We'll figure them out. Keep in mind, to get from term to term, we multiply by r. We multiply by r. We multiply by r. So I think it's true that to get from 6 to -48, we start with 6 and we multiply by r 3 times. And what we end up with when we multiply by r 3 times, we get -48. Solve it. There you go. There's your common ratio, -2. Okay, well now that we know that, let's answer, kind of forgot what it even asks. Find the first term. Okay, Well, if r is -2, back it up 1. First term is -3. Find the common ratio. Oh, we did that already. Find an explicit rule. Okay. A sub n equals first term times r to the n minus 1. There we go. All right. Should be pretty easy stuff. Have fun with that.